My name is Jung-Lynn Jonathan Yang, and I'm the sole creator and sole copyright holder of this graphic that summarizes the concept of the inflection point in calculus. This graphic is made for my own personal use. I'm making this work in progress video to demonstrate that this is my original work. I provide several examples about how to spot an inflection point on a graph. I have split up these examples into two categories: from concave up to concave down, or concave down to concave up. In either case, the inflection point is the point on the graph where the curve changes concavity. In the topmost row, the second derivative is 0 at the inflection point. The reason is because that for transition from concave up to concave down, the second derivative starts out positive, becomes less positive, and then eventually goes to 0, and then becomes negative as the graph becomes concave down. The opposite is the case from concave down to concave up in the column on the right. The second derivative starts out negative in this region of graph that is curving downward, and then the second derivative becomes less and less negative and more positive after the inflection point, where the curve is now concave up. The other examples on this graphic involve a non-differentiable point, but this non-differential point is nonetheless continuous on a graph. The second derivative is d/e, it doesn't exist, for two reasons. The first reason on the second row is for a vertical tangent line. A graph that has vertical slope has a slope of magnitude infinity, and infinity is not an actual number, which is why it doesn't exist. But for the third and fourth row graphs, the reason why that inflection point is not differentiable is because it's too sharp. There's such a huge... The left limit and the right limit in the slope definition doesn't equal to each other, and because the slope is a limit, the limit doesn't exist. For these d/e cases, the reason why these points that I have highlighted are inflection points is because there is a transition between concave up to concave down, or concave down to concave up.